Okay, so this session is called peer instruction. It's an active learning technique, and it's for improving learning and engagement. In this session especially, this is what your role will be. Everybody recognize this gentleman? Yeah? So these are, who's this circle? Teachers, and this is younger learners, you're older learners. And then look at these arrows. This way and then going back. So in this session, your role will go back and forth between that of a teacher and that of a student, and the slides will mention. We did a bit of that even in the previous session, but it will be a lot more here. So this is just something to keep in mind. Okay, so the next question is on a blue slide. I'm going to ask you to vote individually first and then discuss with your neighbors. This is the only question which has some technical part to it. Okay, it's not about teaching or learning. It's actually about some coin toss. You don't need to be a maths teacher. You don't even need to know the word probability or something. Everybody has played with coins. So there'll be 4 choices. Think for a moment. When I say vote, please vote 1, 2, 3, 4, and then we'll do a discussion. In a moment, I'll say talk with your neighbor and vote. But right now, vote individually. Okay, so now what I want you to do, I'll give you a couple of leading questions. Think about that, then talk to your neighbor. The leading question is this. You have 2 coins. You're tossing it. So if you want to find out about outcomes, suppose you had only 1 coin. Okay, suppose you had only 1 coin. How would you figure out what would you do to figure out about the outcomes? Think about that question. Suppose I had only 1 coin, what would I do? And apply the same process if you had 2 coins. Okay, so now, still you're in student mode. Discuss with your neighbor. Think about these 2 questions. What would I do to figure out if I had only 1 coin? And how can I apply it to 2 coins? Okay, did any of you, I'm not asking you to vote. Did any of you change your answer? Nobody changed your answer? Not, some people, no, I'm asking, have you changed your answer, yes? Some of you changed your answer. Okay, so one more thing. So now let's do this together. If you had only 1 coin, what are the outcomes? Okay, you have 1 coin, and you have head and tail. Now, discuss this with your neighbor. 2 coins, use the same process. Don't simply guess. Use the same process. You said this coin can be a head or it can go that way to a tail. Use the same process, talk to each other, and 1 more minute of discussion. So one more question. In how many groups is there disagreement? You and your neighbor don't agree? Anybody? You all agree with your neighbor? Okay. How many of you changed the answer now? Some of you changed your answer. So, can you explain what you changed from?
Earlier it was 4, option 4. I thought that there is possibility of head or tail. And if we combine that, I thought these are equally likely. The probability of all these events. But when I combined these H and T, I found that the probability of 1 head and 1 tail is now twice. The possibility is HT. Now there can be one more. Old coin will be T and the new one will be H. So these are 2 events, same events. 1 head and 1 tail. And yes, this is the answer. So the first 2 are same, so they are twice likely. The probability of those events are twice.
Okay, so now I'm going to ask all of you to change your role to that of a teacher. Okay, this was an illustrative example. Did you understand the explanation? Does anybody have a doubt about what is happening? This activity, this kind of question, It goes by the name of peer instruction, okay? Multiple things are happening. So in order to deconstruct this method, let's actually see what all you did. And actually, let's go through this together. Instead of doing it as yet another activity, we'll do it together. So individually, let's just share as a group, what all did you do as an individual? Let me start with the first one. You read the question and you came up with some answer. What else did you do in the second phase and the third phase? Especially those who changed their answer. There are at least 10 people who raised their hand. If you change your answer, what were you doing when you were talking with someone? Arguing? You were reviewing each other's, you were arguing. If somebody had a different answer in your group, you were thinking, what is happening? How come that person has a different answer? What did the instructor do? Actually, we don't need all this. Let's just stick to this one. What did I do? I gave you some hints to analyze. The hints were more in the form of questions. There was only one hint, which was write your answers in a notebook. And then the other thing I did is saw who changed their answer and asked one of them to talk about their answer. Okay, so this method is called peer instruction. What happens in this method is that the teacher asks a question and there may be individual voting. Then there is a phase where discussion happens. In the discussion, a lot of things happen. You are reviewing each other's thought process, not just answers. You're thinking about each other's thought process. You are trying to see, if you had a different answer than your neighbor, you're trying to see why is their answer different. You may be listening to them and trying to learn from what they're saying. You vote again, or maybe you're given a hint to do something again. And then there's a debriefing or a class discussion. Debriefing is what happened there. All of it is with the entire class. So I was timing it from the time the first question was posed till you gave your answer. It was about 4 minutes. I was actually looking at the clock. It seemed like a lot more or a lot less, I don't know. It was about 4 minutes, okay, this whole thing, this entire process. So, before showing you an example, let's talk a little bit about this. Questions which are conceptual in nature, not questions which have a very quick plug and chug, but conceptual questions, questions where there is room for students' alternate conceptions, questions to bring out students' prior knowledge, questions to exactly clarify what it means to calculate the outcome, the probability of an event. See, that's a concept. Probability of an event is a concept. And there is a process to doing it. This is the process. Every textbook says list the events. But in the first round, none of the audience members listed the events. The moment you get that idea, oh, I have to list the events. And there was a step in between that if you had only one head, one coin, listing the events is very simple. You sort of are scaffolded through it. So all these are elements of this method. Okay. I'm going to show you one more example. This is actually with, believe it or not, it's from a JEE coaching class, okay, for 11th standard students, and they use it quite effectively. Okay, you can take a look. There is an audio to this, it's okay if you don't hear it. The teacher now said, "Aap discuss karo." If you hear this video, at this stage, there's a lot of noise in the class. It's good noise. Okay, this is the second vote, and 80% of the class converged. Okay, so what is peer instruction? It's a classroom active learning strategy. Exploits the power of peer learning. It's also what's called a formative assessment strategy, where there are questions posed. It is assessment, but it is called assessment for learning. It's not assessment of what the student is knowing. It provides feedback to students and to teachers, it says. So how does this provide feedback to teachers? And to students, okay, they get to know about their reasoning, they get to know what's right and wrong. But why does this provide feedback to students? To the teachers? Maximum, or especially if there is a gross problem, like if 50% of the students have not answered yellow, and let's say yellow is the right choice, as you saw there. Or in the example we did, if most of the class is answering choice 4 and 3 is the right choice, the teacher knows that, oops, there's a problem. So the probability question happens just after the teacher has explained about events and probability in calculating outcomes, sample space, or the space of possible events and all that. And then if most people are not able to do it, the teacher knows that something different has to be done. And this is an effective strategy when the teacher creates and implements careful, well-designed questions. This won't work with every question, but it has to be carefully done. It's a multiple choice question. It's conceptual in nature, and so on. So what we'll look a little bit more about the benefits and the features and examples, and then you can write a few questions for your own classes. So let's look a little bit more about the benefits. Can you think about the benefits to students? What are the benefits to students if such an activity is done in the class? Just say one by one. You can raise your hand so that you know. There is some practice, okay, excellent. They are thinking and reasoning. See, the main thing is, if you noticed, it's not only about choosing the right answer. It's about the process of reasoning. So they are doing reasoning. What else are they doing? It's engaging. So during those 4 minutes, even most of you in the back were also doing something on task. The moment I start talking, I see mobile phones are coming out, people are tuning out and all. But the moment it's talk to each other about this interesting question, everybody is like, what's happening? So engagement is very high. What else is happening to students? They are developing confidence because they are actually answering questions and talking. They are thinking and reasoning, so they are changing their ideas. Think about what happens when they are talking with their peers. Think, those of you who changed your answers, what was happening when you were talking to your next door neighbors? You can clear doubts. What else? You can get more different perspectives. So all of these help the reasoning. And also, if you remember, I told you to fight with your neighbor and try to convince them of your answer. So your reasoning gets clearer and your communication skills also improve. So this method for students, they talk, argue, listen. Sometimes they listen, sometimes they don't. But at least there's a lot of reasoning happening, which means they're actively engaged. Then the second point is important. Students are teaching each other. The moment you teach somebody something, you learn it much better. So this technique also has that benefit. And then a few other things. Those who don't know anything, or not know anything, those who don't have a clear understanding, they're willing to engage because it's an easy enough question. Nobody asks the students to, memorize and write some formula. It's something that everybody can jump into. So even if they don't have strong prior knowledge, they'll get in. Those who do have strong prior knowledge also get in because they want to argue and they want to show off their choice, their understanding. So students' pre-existing ideas comes out. It's called elicit, confront, and resolve. Okay. So a lot of things happen, a lot of positive things happen in terms of students' reasoning, understanding, and engagement in this method. For teachers, we discussed earlier. So there's immediate feedback to the instructor. students realize, so this is the second point here. This is an important point to the class atmosphere. Students realize, every student sees that others are also struggling. They see that they're not the only one who doesn't know the topic or who has a wrong answer. So that builds, or that lessens the feeling of being daunted. Otherwise, there are many students in our class who are afraid. They think that that person is smart, I am the not so smart one. That doesn't happen. Because everybody is allowed to make mistakes, and it's a safe space. It's okay if everybody makes a mistake, because the rule is no penalty for wrong answers. So there is a safe, confident atmosphere that's created, but allows for scientific debate and disagreement, and improving communication. So there's a lot of research on this method, and the reason this research is important is that these are very carefully done empirical experimental studies. All the variables are controlled, and in many topics, actually this 300 is perhaps now 400 or 500. This statement is a few years old. And people have measured conceptual understanding, problem solving skills, attendance. In classes where attendance is not mandatory, it has improved actually. They have measured motivation, they have measured learning from peers, student perceptions, all these have gone up. So here is an example of an article. This itself is from 2000, okay, we are now 20 years later. It says 10 years of experience and results. So when we say education research based methods, this is one of the strong ones. Many people in physics, computer science, it was sort of pioneered in physics about sometime in the 1990s. But now you will find questions like this being done in computer science classrooms, electrical engineering, psychology, political science, biology has started doing things. So in a variety of fields and many school level topics as well as college level topics, people have done these experiments. So strategies like this can be used in multiple domains. So the first one was actually using technology called clickers. Kaun Banega Crorepati, remember? You know, that was what was popular in the 1990s and 2000s. So students would actually press their choice and the teacher would see a histogram of what the different choices, especially in a class of 300, it's great to have that technology. Suppose you say, I don't have that technology, like today here we don't have it. What can we do? We can do flashcards like you saw in the video. So I'm going down in technology, I'll come up in a minute. So sound is a concern, yeah, that is a fixable issue. So how to implement it? You can use flashcards, color flashcards, or a very simple thing to do is, let me just show you how to do it with a plain piece of paper. You have an A4 sized piece of paper, which everybody has in their notebooks like this. Okay, ask students to simply write the choices, maybe using different colors, or if that is not possible, even with the same color is also okay. And then they can hold it up. So let's see, somebody from the last row, can you see this? Yeah. Otherwise make it a little bigger. So either you use colored cards like that, or just this takes 5 seconds to make and it can even be thrown away. So this is one way of doing it. Suppose you don't even want to do this. So today I didn't want to go through the hassle of doing this because I was going to do only one question. You can use fingers like we did. Okay, it's sort of the least low-tech technology. Then the ones which I actually use in my classes now is our online fora or online platforms, on which I can create a question and students answer that question and access that question using some software called Mentimeter, Socrative. There are many platforms, they're free of cost, and you can set up a question. Let me see, maybe for tomorrow we'll do something like this. So one is called Mentimeter, one is called Socrative. You create an account, you populate a question, it gives you a code. Share the code with students and they can vote. This requires a smartphone or a tablet or a computer. And don't be afraid of those technologies. So in fact, in my MTech and PhD level, Masters and PhD level classes, I let students use that. And then, this is sort of something I haven't used, but I've heard of it. I've seen a video. So every student has a piece of paper which has different images using different colors. Maybe you will be able to see it here. And then there's an optical recognition camera in the front of the classroom which is actually reading the distribution and showing how many have answered which. So the role of technology, if you see, peer instruction is not only about the technology. It's not about voting. It's not about clickers. It's not about flashcards. It's not about Mentimeter. That's only the implementation strategy. But the actual peer instruction is peer instruction. The part which happens when the students talk to each other and the part where the teacher is guiding and facilitating that discussion. So coming to the issue of sound, this is another problem that we get from teachers. It is an issue, especially if, if your classroom is not soundproof at all, of course it may be a disturbance, but the actual discussion happens for maybe a minute or 2 minutes at most. After that, people are back and the classroom is as silent as this. Sometimes we've had principals and HODs complain. So if you are an HOD, please don't complain when your faculty are doing useful techniques. Help them make the room more soundproof. If you want to convince your principal that this is a good idea, show them. So in all industry, people use this method. And there are 300 plus research articles showing that this method improves attendance, improves motivation. It will improve teachers, the student perceptions, and so on. So and if you have a supportive management, you can even ask them to buy the technology. Though these days, with this online platforms, almost people have stopped buying technology. About 5 years ago, RF clickers and infrared clickers were very popular. But they're still available. The parts of the method that you must have are these. Actually, sometimes you don't even need to do the first vote. You can directly ask your students to start discussing. There is one part in this diagram that you absolutely should not skip, and that is the peer discussion part. This is not skippable. This particular method is for multiple choice questions, yes. What about long answer questions? There are other methods. Tomorrow we'll do one of them called Think Pair Share. Okay. This method is for multiple choice questions, and as maybe you were hinting, the hardest part of implementing such questions is writing these questions. Because these questions cannot be of a trivial, what is the definition of this? Those questions don't work. But there are techniques, there are processes, there are methods to write good questions in every field, which is what we'll spend the next half an hour on. Other questions? Noise is an issue. Don't be afraid of noise. It's very good noise because that's where all the learning is happening. Other doubts, or you want to try it but you're not sure? See, engagement improves a lot. That is one thing definite. If you want to do a study about learning, you have to do it a few times. That's not so straightforward to do, but it is still possible. Shall we try to start writing our own questions? We'll look at examples, different types of examples, and then we'll try to write similar questions. Writing your own PI questions. So here, there are guidelines for writing different types of questions. We'll go through some types. You can examine if this is suitable for your course and you can write your own question. Here are some top level recommendations for writing effective peer instruction questions. So an effective peer instruction question is usually conceptual. Avoid long problems. For that, there are other methods which we'll do tomorrow. It should elicit students' prior knowledge, their pre-existing thinking. Like in the probability example, we saw the coin toss example. It is known that students struggle, everybody, not just students. People struggle with this idea of events and how to do it. So it's known that this is something that the prior knowledge that everybody comes with, and the question should target, it should elicit this out of the students. The distractors should be believable. If choices A, B, C, D should not be obvious that B is the right answer. Then, here are some good ideas. We'll actually come to the ideas in the examples. Some don'ts, it should not be ambiguous, it should not be leading. It should not be too easy or too difficult. So we'll see how to do this. Okay, let's get to it. So now you are in the role of a teacher from now on. You'll see a lot of examples from different domains. You'll see a lot of examples. The point is not to answer the questions unless I ask you to. But the point is to see why the question displayed there is a good question, or what are the advantages of a question displayed there. That's the main point. Okay, so we'll walk through a few examples. Here is an example from some 8th standard environmental science or so. It says a small acorn is one of the seeds of a tree, can grow into a huge oak tree over time. The tree weighs many tons and the acorn is just a few grams. Where does most of the mass come from as the tree grows? Hey, if people want to do some other work other than this, may I just ask you to use the space outside because it's disturbing for everybody else. So if you want to stay in the room, please be on task. Okay, nobody is taking attendance here. But if you're not going to be discussing what's being discussed here, then please, there's lots of space outside. So, see this question, where does most of the mass come from as the tree grows? Why is this? Why do you think this is suitable as a peer instruction question? Okay, let's definitely to make the people think and reason. Okay, those are always there. Let's try to get more specific. What is unusual about this question? Let's start from that angle. All the options of the distractors seem to be reasonable. And who said something? Yeah. All the above is also a possible answer. By the way, do you know the answer to this very easily, evidently? Maybe you have heard of it. But as somebody said, all the others also seem to be, it could be the soil. So they each, especially for somebody who's thinking of it for the first time. Sunlight also plays a role, but so the thing is, all answers require reasoning here. It's not a trivial question. So a few minutes ago we said the question should not be too trivial. This is not a memorization question unless they've seen it before. That's a different point. Even if you say gases in the air, that seems very odd. Gases, gas seems to be so light. How can a gas give rise to a mass of a tree? That is also a question worth thinking about. So conceptual questions which require reasoning of this sort are useful questions. In engineering, engineering and science, questions like this are also common. These are kind of questions we saw in the first session. What happens if you change something? In this case, you don't need to know the domain at all, okay? But the idea is that there are two variables. One variable is changed. What happens to the other? Does it increase, decrease, or stay the same? Does the brightness increase, decrease, or stay the same? Does the program take longer to compile or shorter to compile? Does the concentration increase or decrease? Does the color go more towards red or more towards blue? Does the mass become bigger or smaller? So anytime you want to use these change of variables but without numbers, it's a very good pure instruction question. So, can we maybe take a minute here? No, I'll give you a couple of other questions like this and then a couple of other examples and then ask you to write your own question. So this conceptual reasoning question asks if some quantity increases, decreases, or stay the same as another quantity is varied. Okay, here is a third question from Geography Secondary School. What would happen to the seasons if the Earth's orbit around the Sun was made a perfect circle? Everyone knows it's elliptical. If we make it a perfect circle, so what would happen if question? Okay. Nothing else was changed. Would there be no seasons, or would the seasons be same as they are today, or the North Hemisphere would be always hot, or various choices are there. Try this at home. It's because we can, for each of these questions, the choices seem very reasonable. And you have to really get into the core of the concept. What does this elliptical shape, how does the elliptical shape affect the seasons? What really affects the seasons? All those questions have to be discussed. This is something like 6th or 7th standard. But you can take heart, some similar question was asked to people who graduated from Harvard University, and a videotape has been made on that. Most people did not get it right in their first try because it's really one of those conceptual reasoning questions. So, for your own topic, take a few minutes. Write a questions that involves this sort of conceptual reasoning. What happens, what would happen if something changed? Right, and let's share a few, and then we'll look at one more different type of question. You can work with a partner or on your own. It's up to you. Anybody wants to share your question? Both the stem of the question and the choices. What we'll do is when you talk about your question, we'll also look at the choices. Okay? Especially if you did not get a chance to write, to get feedback on your question in the first session, this is a good time to get feedback on your question. Grain size. Okay, and this is in which topic? Manufacturing. Okay, if grain size is more, what happens to permeability? You can ask that. What will be your choices? Increase, decrease, not change. Okay, fair enough. Definitely.
If I have to increase the strength of a bolted connection,
Okay.
what will I do?
Okay.
Increase the diameter of bolts, increase the number of, if I had to increase the strength of the connection economically, what will I do?
Okay.
Increase the diameter of bolts, increase the number of bolts, increase the grade of bolts.
Okay, thanks. Again, this is a question where different variables come into play, but it's not only about increase, decrease, stay the same of the same variable. It is how do 3 different variables or parameters affect the strength of the connection. So this is definitely one more question. Can we hear something not from manufacturing, engineering, just for diversity? Yes, sir.
This is Dr. K.K. Yadav from Agriculture University, Udaipur.
Yeah.
My question is, gas released by a plant during respiration. Options are oxygen, carbon dioxide, hydrogen, and nitrogen.
Okay, so which class is this question for? I mean, which level of students?
Level of student may be 6th standard.
6th or 7th standard. Okay, so let's take a question like this. What are the gases released during respiration? Oxygen, carbon dioxide, nitrogen, and so on. There are one more question or one more point we have to think about as a teacher is when in the teaching cycle for a topic do we want to give such a question. So you can do peer instruction either before you teach the topic or just after you teach the topic or maybe long time after you teach the topic and so on. It depends on how much reasoning you want your students to do. Do you want them to do reasoning based on a principle or a theorem, or do you want them to recall something? So a question like this, actually let me ask, do you think this is a recall level question or is it an apply level question? What is your understand level question? What's your opinion?
Just understanding.
Understand level. You remember the taxonomy we did in the last session? Is it a remember level question or is it about grasping meaning? Is it about solving?
Son?
So some might say recall, some might say understand. It doesn't matter.
But I think more than 50% person here
Yeah.
may be wrong.
Possibly, actually, you may be possibly right. So there are 2 ways to do this question. Actually, I also am not sure of what the right answer is. Okay, it doesn't matter. But suppose you want to start teaching this subject, this topic. Before you actually tell them information about the topic, get everybody to vote on this topic. Especially if you know that there is likely to be a counterintuitive answer, or especially if you know that prior knowledge usually is not very, has a different answer than what the science says. Get people to vote beforehand and then teach your topic. Why I thought of this is that the teacher who, when you said this question, you said most people may have a wrong answer. So it's a good idea before you teach this topic to get this. On the other hand, if you've already taught this topic and said that, look, this is counterintuitive, let's hear the answer that will help us. What do you think is the answer? I mean, what according to you? We all think carbon dioxide. Is that right? Is it carbon dioxide?
No.
No, okay. What is the answer? What is the answer?
Gas released by the plant during respiration.
By a plant. Okay.
Yes.
It's gas released by a plant. I didn't even see that. During respiration. So, it's something else. It's not carbon dioxide. We are not looking at human beings. So, before teaching photosynthesis, you can ask this question.
Yes.
Or if you have taught photosynthesis and the next day you want to, here is another way of doing it. If you want to recap or review what you did yesterday, start off the class with this question. Instead of, see, normally what do? We come to class and say, yesterday we learned the topic of photosynthesis where we saw that plants release oxygen. Instead of doing that, make them do this 2-minute voting question. So questions like this you can do both before and after. Okay, thanks. That's a great discussion. Let us look at a slightly different kind of question, 2-3 more examples, and then you can write your own question. All right, what happens here is the following. You find a video in your domain that is that shows some experiment, preferably something that changes. For example, if you're in chemistry, you can mix 2 colorless liquids and look at color change. Or if you're doing that bulb and battery problem, you can find a video or animation which shows that the bulb has become brighter or less bright when you change some circuit. In this case, what's happening is, I would have loved to do this because this is a very counterintuitive thing. What you see on the screen, this is a balloon here, the red thing. It's a helium balloon. It's tied to a thread which you can't see, but that's why it's floating, and the thread is tied to the bottom of this cart. So it's like a cart, gaadi jaise chota, and there is plexiglass, some plastic on all sides. Okay, there is no, it's a standard box which has transparent sides, and the person who's standing there is going to push the cart from the outside. The person is not touching the balloon. The person is going to just push the cart. The balloon is inside and it's suspended inside. So this is done in something like 8th standard or 9th standard, maybe 11th, when motion and forces and all are being discussed. And what the students have to vote about is, will the balloon move as soon as the person pushes? Yes, it will move forward. Yes, it will move backwards, the balloon, backward means towards the person, or will it stay the same? Okay, so this is one place where I want you to all vote. I mean, if I can't show it, I'm going to ask you to go and look at it later. What do you think will happen to the balloon? Will it move forward? Forward, one person. So I'm pushing like this, okay? Will the balloon move backward like that? Backward. Why do you say backward? So you can use some technical terms like inertia, static, kinetic, or there's a third answer which says it will be stationary. Some pressure, so somebody is bringing in pressure. Those of you who said it will move backward, have you had experience of this type where, something moves and then the thing inside moves backward? Car, bus, you're hanging in a bus, the bus moves backward. So, again, all choices are possible. If you say nothing happens to the balloon, what is your reasoning? No relative motion, maybe the balloon is just like 2 or 3 people said forward, 1 person said pressure. So, all these things, all these ideas are there. So, what the teacher does is first pose the question, ask students to vote, and then the answer, the teacher doesn't say the answer. It's not worth saying it because nobody will believe it. So this is a very typical type of peer instruction, very effective peer instruction question. I'll give you one more example of the same kind but not in physics. That's in programming. What is the output of the code? Show a piece of a code. Ask the student to predict the output. Give choices. Don't answer this yourself, okay? Give choices. After every student has voted, just run the program. There's so many, you can run the program on your PC and see what actually happens. So getting students to read a program and predict the output, this is called tracing a program. So getting students to trace a program, predict the output is again a very, it's one of the fundamental skills to understand programming. It's not only about writing programs. This is one of the core skills, both for tracing and for debugging. They need to know what is the output that is likely to happen. They need to be able to trace the logic of the program. So the other similar thing is, if in this program, this piece of a code, if we change the function, if you don't teach programming, you can ignore this. But if you do teach programming, you can do something like this. If we change the function call from function of int x to function of int ampersand x, what will happen? So when you're doing pointers and all, you can ask questions like this. But essentially it's the same. You give a piece of a code, ask students to predict and then run the code, or give them, ask them a question about an experiment. So is predict the outcome, is that a meaningful goal for some of you? Just say, do you think can you think of an experiment in your topic that you teach where you can think of writing a peer instruction question of this type? What experiment doesn't have to be, something done in the lab. Experiment means a phenomena, something that moves. Okay, so anytime, let me take that. Anytime you show demos, do you show demos in your class? Actual demos or video demos? Convert the demo, or before the demo, before showing the demo, create a peer instruction question. So in your case, you have some surface and you have a duster, and the demos, you start tilting it and ask them to see when it starts sliding. What is a peer instruction question you can give? Make them predict at what angle will it start sliding. Make them actually write the answer, and so here some calculation is involved, which is okay. But then put it at that angle and see whether it slides or not. You can use less than or greater than also. At an angle of 20 degrees, the duster will slide or will not slide. That also can be done.
Suppose you want to give the concept of control system to the student of third year, we can have a demo of 2 videos,
Okay.
wherein one, the overhead tank is there, in which you are putting water inside it, but since there is no control, so the water will fall over it.
Okay.
But through a second demo video, you can show a balloon, floating balloon is there. So as soon as the water get filled up, the control mechanism will operate, and thus the switch get off. The
So
water
that's
will
the
not.
demo. So now let's try to convert this demo into a peer instruction question. Before showing the demo, what kind of peer instruction question can you ask where you make the student predict something, or mostly predict something? So you can ask, when the control system is put in, what will happen to the water? Will it flow like earlier or will it be steady? See, all these questions, you have to have the student give some answer. Usually think of getting them to make a prediction. Okay. So take a demo and convert it into a question. That's another way of doing it. These questions, it's recommended that you spend 3 to 6 minutes on these questions, 3 to 6 or 7 minutes. Especially if you're doing a double vote, it will require more time. If it's a single vote, about 3 minutes is enough. Okay. One more category of questions are with graphs and diagrams and other such representations. Any science and engineering field has lots of these. If you open a scientific journal, what is it you see? Any journal, research journal, when you open it, what do you see on it, on a page? Graphs and text, tables, formulae, diagrams. You'll see all of these. You want your students to be able to convert and go back and forth between these. So this is an example. You don't need to know the domain. But the question and the answer, both are in the form of diagrams. The question says, look, here is a graph. Doesn't matter what the graph is. The answers, the choices are, which of these 4 circuit diagrams can give this graph as an output? You want students to be able to answer questions like this. So anytime you have diagrams in your, do you have any specific, domain-specific diagrams? You represent them using diagrams, okay? Graphs, everybody uses functions and graphs. So you can always go between equations and graphs. That's definitely possible. But this one is unusual because it's diagram and graph, which is a little more unusual. But you can always convert text into diagram. So here is an example from English. I really like this example. It's for 3rd standard English. It converts a text, it goes back, students to go back and forth between diagram, simple picture, and text. Which statement out of these best represents this picture? It's all about grammar. I don't want to know the answer from you, but I want to know, why is this a good question? Can some English faculty members help us? Is this a good question, firstly? Small kids, okay, who are learning grammar for the first time. What does this question help the learners understand? Or single and plural at an application level. Not simply memorizing rules, but they look present. Singular and plural also. Look at choice 4. So present, tense, both. Tense is also there, and singular and plural both are there. Articles are there differences in articles here? No, all 4 have the same articles. But there is a difference in the tense, and there's a difference in the singular versus plural. So, how to construct a statement for this figure? There are many apples, but it's up to you. Suppose, so which of the following, look at the question, the way it's worded. Which of the following statements does the picture best represent? Is there a statement for the apple that is still in the tree? None of the statements are about the apple in the tree. So clearly it's not about that apple. Okay? So the question, you have to frame the question, and if you don't like this, color one apple purple, make one apple green, do whatever you want. You are free to set the question. It should not be ambiguous. Your point is well taken. An apple, you can call it an apple also. You can change the question, no problem. If you have to see which one is less ambiguous. If you say an apple is about to fall from the tree, you have to, you have to see which one suits the best. Okay? We did discuss this. You can always recall points, give questions to recall points from previous lectures. We did this with the gases example. And this is something you can do at the beginning. If you're teaching a class for the first time and you want to know about so this was, we were teaching a programming class for a class of 250. And first year programming class. So we did not know their background. So we wanted to know what is their actual experience with programming. Are they familiar? Did they learn a little as a hobby? Did they have it as a subject? Or did they go to Olympiads? It was 2-minute question. We got a feel that there were some 40% of the people here, 20% here, and so on and so forth. This is not for double discussion, not for peer discussion, of course. This is just a survey question. You can do such questions over Moodle also. These questions are best done where you can store the answers. So if you have a way of capturing the data, for Moodle, this is actually one of the best questions. It's not a peer discussion question. It's only to know about your participants. So here is a question I want to ask you. This is a genuine question, the one I'm asking next. There you have to answer like a learner, okay? Because I would like to know, will you use active learning techniques such as peer instruction? Think, pair, share you haven't done, but take peer instruction in your class this semester. Not at all. I will use it at least once. I will try to implement it once a week, or I will do so in each class. So not at all. Actually, I'm not interested in who's saying it. I just want to get a feel. The reason is, initially, until you iron out your technique. So I've been doing this technique for 15 years, okay? So I know what works, what doesn't work. Still, sometimes things flop. If you say I'm going to do it in every class and something flops in the first 2 classes, you're going to stop, which is terrible. So aim for something medium. You can try once a week, or if you're skeptical, say I'm going to try it not once, I'll say try it 3 times. Why I'm saying 3 times is because it takes about 3 times for students to become comfortable, and it takes you 3 times to get confident. The first time things are not going to go okay. Don't worry about it. By the 3rd time it will. A big concern. So let's maybe come to your concerns. Your concerns. Okay, let's start with your concerns. One of the concerns was that of noise, which you brought up. Any other major concerns? I'm expecting one more big one. Those of you who will do it every class. Syllabus is not covered, of course. Pace of the class. Definitely, it is a valid point. So there are some solutions. I mean, some things you can try. Start small. Say I'm going to try it once a week. It takes 5 to 7 minutes. You can afford that much time. If you don't like once a week, say I'm going to do it once every 2 weeks. That's okay. Second thing you can do is remember that a question like this is actually quote unquote covering a lot of syllabus in that. Let's take the probability question. If you normally spend, how much time will you spend, do you think, to explain this concept of events and sample space and all that? 15 minutes or so to explain. The extra 5 minutes you spend is time very well spent because those 15 minutes become useful. Otherwise, those 15 minutes are useless because everybody in the class had a misconception. So pick topics where you know that prior knowledge might be a problem or application might be a problem and choose wisely. Those extra few minutes are like really, you don't have to do homework, you don't have to do many more examples. You do one such question and you don't have to explain 5 examples. You can do 2 examples using this. So syllabus coverage is not only about the teacher speaking, it's also about what the students do. So this noise and syllabus coverage are the most important ones. Some others that come up, lack of interest. What to do if the students are quiet and they don't answer? Here there was no problem, but what do? Can happen. Start working. So the very first thing you do is maintain silence. Okay, what I mean is this. My postdoc advisor taught me when you ask a question, she asked how many seconds should you wait before somebody answers? And apparently somewhere in literature, I haven't found a source, but she said it should be 6 seconds. Okay? 6 seconds is excruciatingly long. It's very uncomfortable to keep silent for 6 seconds. So let's say I ask you I ask everybody a question, and let's say there's dead silence. Wait for 6 to 10 seconds. Don't say anything. It's a long time. It feels uncomfortable and you may want to say something. But if your students see that the teacher is not saying anything, some student will speak up. The moment one speaks up, the second and the third will speak up. So the very first thing, don't do anything for 10 seconds. Then it's not a good idea to say, the gentleman in the red shirt, please answer because I'm putting you on the spot. It's not a good idea. But what you can say is, can somebody from the right side answer? No individual is put on the spot, yet there is some accountability. And if the students see that you are serious as a teacher, they may not answer in the first class, but in the second and third class, they'll start answering. So that's why I said try it for 3 times. So students not answering is a problem to begin with. It's always a problem. But that's one of the first things that goes away. Student disturbance and noise, you'll have to somehow lobby your college to get better rooms or do it for a short time and so on. Okay, the last one. This class will get chaotic. How do I get students back? Everybody is doing peer discussion and then it gets very chaotic. I lose control of my class. So this one I learned from a primary school teacher. They use a bell or something. Or they use a balloon. The moment the teacher shows a balloon, everybody should keep quiet. It seems there's a rule in their class. So I pick up my water bottle and there is something metallic. You can start increasing the noise of it. It's funny. People don't expect it. You can do that. Or even here, sometimes silence works. If you find that some people are disturbing the class, just become very silent and look in their direction. And that also works. So these are sort of this is not part of education research, but standard classroom techniques. Okay? So, these slides will be there. There are a lot of other recommendations and all. This is the main one. Try not to assign marks for these questions. At most, like 2 marks for the whole semester. Some marks, 2 marks is a good idea because like one of you mentioned, students may not take it seriously without marks. But if you give too much marks, too much weightage, they won't respond freely. They will start thinking of the marks.